These are the solutions to November 2024 M4 Mathematics. It is paper 1, which is a non-calculator paper. So our first question, unusual sort of question, this is to do with angles and polygons. It says in the question we have to find this angle in here. So to find this, we need to find our angle in our rectangle and our angle in our regular pentagon. So the rectangle one is easy. We should know in a rectangle all angles are 90 degrees. For the pentagon, we're going to use the sum of the interiors formula, which is n minus 2 times 180. So that's going to be 5 minus 2, because n is your number of sides, times 180, which is 3 times 180, which works out to be 540. So that's for all 5 of the angles. Now, if it's a regular pentagon, then all angles are the same. So do 540 divided by 5. 500 divided by 5 would be 100. 40 divided by 5 would be 8, so 108 degrees. So this angle in here is 108 degrees. Now we can find our angle EDM, what we're looking for, by taking 360 and taking away your 90 and taking away 108. So that's going to be 270 minus 108. And 270 minus 100 would be 100. And then 170, and then minus another 8 is 162 degrees. Next question says, Kevin tosses a coin. He knows it's biased, which means he knows it's unfair. It lands 60 times on heads. Kevin uses his experiment to work out that the relative frequency of his coin landing on heads is 2/3. How many times does Kevin toss a coin? So he knows 2/3 is 60 times. 1/3, divide that by 2 would be 30 times. And then 3/3, the total amount, is 30 times 3, which is 90 times. Next question says, and this was a tricky wee question, it says, Katie uses flour to make muffins. She uses an equal amount of flour for each muffin. To begin, she made 3 muffins and had 3/4 of her flour left. So 3 muffins, that means it must take up 1/4 of the flour. That means 1 muffin, if we divide that by 3, is just 1/12 of the flour. Next one says, Katie then made another 7, so that's 10 in total, and had 50 grams of flour left. How many? So 10 muffins is in 10/12. Remember, we worked out 1 muffin was 1/12. That means 2/12, what she had left, is equal to 50 grams. And we need to work out how much she uses for each muffin. So 1 muffin, remember, was 1/12. So divide this by 2, you'll get 25 grams. Okay, next question says, you've got this weird shape here, rectangle divided up into triangles. The area of the triangle is 120 centimeters. So triangle C, let's just write it in when we get it. Triangle C is 120 centimeters squared, which is half of the area of the rectangle. That means the rectangle is 2 times that, so it's 240. And then it says triangle A, the ratio of triangle A to the area of the rectangle is 1:4. That means triangle A is 1/4 of the rectangle. So 240 divided by 4 is just going to be 60 centimeters squared. Triangle D is 240 divided by 6, which is 40 centimeters squared. And what you've got to find is triangle B. So triangle B is the only thing that's left. So triangle B is going to be the whole rectangle minus triangle C, minus triangle A, minus triangle B. So let's just work that out. 240 minus 120 is 120, minus another 60 is just 60, and 60 minus 40 is just 20, and that's going to be centimeters squared. Okay, this is a similar triangles question. So it says A and B are similar triangles, work out X. So X is on the small triangle, its corresponding side is 15. Another side in the small triangle is 4, and its corresponding side is 10. So let's just cross multiply here. You'll have 10x is equal to 15 times 4. 10x is equal to 60. x then is equal to 60 divided by 10. It is 6 centimetres. Another way, there's a couple of ways of doing this one, but another way of doing it is scale factor. You could say that 10 goes to 4, and you get there by multiplying by 4 over 10. That means that 15 goes to x, and you get there by multiplying by 4 over 10 as well. I'm just going to write that in. That means x is equal to 15. I'll write it's 15 over 1 times 4 over 10. And then I would do a wee bit of cancelling down. 15 divides by 5 to give you 3. 10 divides by 5 to give you 2. Then we have 3 over 1 times 4 over 2. That's 12 over 2. So x is equal to 6 centimetres. So there's a couple of ways of doing that. Same question. Next one. Write 4.63 in standard form, non-calculator remember, so that's making a number between 1 and 10, so 4.63. And then if you think this is where the 4 is, and it needs to move once and twice to get back, sorry, I'll zoom in on that. So if you imagine, I've just changed my 4 to make it, put it here, and it needs to move once and twice, so it's times 10 squared to the power 2. So 4.63 times 10 to the power 2. Next one, lovely wee question. This is about reordering multiplications. So we could change this to do 4 times 5 first, and times 10 to the power 3 times 10 to the power minus 4. And that is 20, and then times adding your powers, that's 10 to the minus 1. And then what we need to do is make this one 10 times smaller. So you've done that by dividing by 10. That means this one here needs to be 10 times bigger. So 10 to the minus 1 times 10 is 10 to the power 0. And that is it. And that's just 2. Oh, we didn't even have to do that, sorry, we just had to work it out. So 20 times 10 to the minus 2, but there we are. 10 to the minus 1. Happy days, that's got us the right answer anyway. Okay, next one, what are we on to? Question 7. 2 students from sixth form are given an opportunity to go to a trip to London to represent their school. A student is taken at random from year 13 and a student is taken at random from year 14. The number of girls and boys are given in a table. Complete the probability tree. Okay, so I'm going to have girls from year 13, and boys, and then girls and boys from year 14. So from year 13, there's a total of 90. From year 14, there's a total of 80. So girls from year 13, there's 45 over 90. Boys, there's 45 over 90. Girls from year 14, there's 50 over 80. And then 30 boys out of 80. 50 over 80. And 30 boys out of 80. Let me just zoom in so we can see that a wee bit better. So that's what you've got for your tree diagram. Complete the tree diagram, done. It says, what is probably that 2 boys go on a trip? So that means I need a boy from year 13 and I need a boy from year 14. So for this one, the probability of 2 boys, so probability of a boy and a boy is 45 over 90 times 30 over 80. Remember, this is non-calculator. 45 over 90 is a half. 30 over 80 is 3 over 8. And multiplying on top, you'll get 3. Multiplying on the bottom, you'll get 16. That's as good as we can go. Question 8. Lovely wee indices question. Okay, right. Multiply this out. You've just got your 4. Multiply out your x. X squared times x cubed is x to the 5. Multiply out your y. Y cubed times y to the 4 is y to the power 7. There we go. 2 marks. Pretty easy. Next one says, rearrange and make x a subject. There's 2 things going on here. Your x is being squared, then you're multiplying by a. So reverse the multiplying by a first, which is dividing. So opposite of multiplying by a is dividing by a. And the opposite of squaring is square root. And you really shouldn't get your full marks for what I've just written. You need your plus and your minus, so the positive and negative square root. 2 easy marks there. I'd imagine that's a mark. And your final mark. Okay, this one, next one's difficult for me to show on this. What you're to do is draw the image of the triangle after an enlargement. Let me just write this in. Scale factor equal to minus a half, and my centre of enlargement is 0, 2. Should have written that somewhere else so I can actually see it. Okay, so 0, 2 is here first of all. And how you would do this using your ruler, which I haven't got, you would draw a wee line from here to here, and you can see what that is. It's 2 diagonal squares. So scale factor minus a half. So 2 times a half, first of all, is just 1. So I'm going to be going 1 diagonal square, but the minus means I go the opposite side of the centre of enlargement, so I go back to here. So this is where this first point goes. That was the easy one I've done. Next one, not so easy. That's what I've got. If I go back half of that distance, I will go back to here. There's one of my points. And the last one, again, so we're getting harder and harder. That's where I go, and if I go back that direction, I go, and half of it, I go back to here. So that's, there we have it. I'm going to do this in red then, link this up. You, of course, use a ruler. But you can check here and see, this is length, this is length 2, this is length 1, and what else we got? This was length 6, and this is length 3, so it does look all right. Let me get rid of that mess and see. So we can still see it looking good. Okay, right, lovely. You can see it. That does look pretty good there. Looks okay. Okay, what are we on to? Sketch a graph of y equals 6 over x on the grid below. Okay, I would do this out and work this out. Then I'll do a table of values. It is just a sketch now, but it's 3 marks for it, so I think they probably want you to do this. I'm not 100% sure, to be honest, but I would imagine they would want you to do this. So it goes from, my x values go from 1 to 6. I think I would just do those out, 1 to 6. It nearly makes it easier having them. 1, 2, 3, 4, 5, and 6. So my y value, how I get this first y value, it's 6 divided by 1, so it's just 6. The next one is 6 divided by 2, so 3. 6 divided by 3, 2. 6 divided by 4, which would be 1.5. 6 divided by 5, so think about what that is. 6 over 5 is just 1 1/5, which is 1.2, and 6 divided by 6 would give me 1. Now what I'm also going to do is I'll do, no, I've got this out of order. I'll do 0.5. 6 divided by half would be 12. So I've actually got 7 values to plot. So at a half, I'm at 12. At 1, I'm at 6. At 5, at 1 I'm at 6. At 2 I'm at 3, I should have said. At 2 I'm at 3. Wherever 3 is here. At 3 I'm at 2. And then this is where it gets a wee bit trickier. At 4 I'm at 1.5. At 5 I'm at 1.2. So zoom in here. 1.2 would be here. And at 6 I was at 1. Okay, it's almost impossible for me to draw this out nicely, folks. Apologies. Oh, here. That's as good as I'm ever going to do on this thing, so I'll stick with that. So there we are. So that's my graph of y is equal to 6 over x. And I would label it, just good practice. Whether you get a mark for labeling it or not, I don't know, but a good practice to do so anyway. So that's 11a. 11b says, use your graph to estimate the value of 6 over 3.2. So that means your x is equal to your x equals 3.2, and we need to find what y is, basically. So at 3.7, if you 3.7, you go up at 3.7 and across. Again, you use a ruler to do this. Up at 3.7 and across. And when I did that on my proper graph, what I got was basically 1.5. Yep, and even on this one, my very bad one here, you can see that, but use a ruler. Do as I say, not as I do. So I got y was equal to 1.5. So that's my answer. Next one says the curved surface area of a cone is 6 pi. If x is a radius of the base of the cone, what does y represent? Right. Okay, so y, first of all, if x is a radius of the base of the cone, so instead of your x, write r, and then we'll work this out then as well. So the curved surface area of the cone is 6 pi. So curved surface area is 6 pi. 6 pi equals, remember, curved surface area is pi RL. 6 pi then, divided by pi r would be equal to L, which means 6 over the pi's just cancel. 6 over r is equal to L, and you can't highlight in your exam, but you've got L is equal to 6 over r. Pi is equal to 6 over r as well. So that means your 6 over r is equal to L, therefore your y is equal to L as well. So y represents the slant height. Did not like that question at all. Thought it was very confusing. Very confusing question. What I did like is your lovely coordinate geometry question, and this is about circles as well. So it says PQ is the diameter of a circle whose equation is x squared plus y squared equals 90. 2, 6 is a point on the diameter. Write down the equation of the diameter. So let's just draw a wee diagram. This thing here is the equation of a circle which goes through the origin. This has a centrally origin. So 2, 6 would be very roughly 2, 6 would be here. So if that's 2, 6, if it's a diameter, it goes through 2, 6. It also goes through the origin. So we have got 2, 6 and another point. Is 0, 0. So your gradient is equal to 6 minus 0 over 2 minus 0. Your gradient is equal to 3. So y is equal to 3x plus c. Now it goes through the origin, so you can see that the intercept is 0. If you don't see that, just put it in. So put in 0, 0. 0 is equal to 3 times 0, which is 0, plus c. Your c is equal to 0. So your equation is y is equal to 3. Oh, should have written it here. Y is equal to 3x. So it has a gradient of 3. So your m is 3, and the intercept is also 0. So just y equals 3x. Next one says find the coordinates of P and Q. Okay, right. I've made a mistake in my diagram then. So 2, 6 is some point on your diameter. So 2, 6 is here then. So it didn't say, I read that question wrong. It says 2, 6 is a point in the diameter. It didn't say it was an end point. But we have to find the points P and Q. So what we want to do is we want to substitute y equals 3x into our equation of our circle, which is x squared plus y squared equals 90. So instead of writing y, you're going to write 3x. Okay, notice it's 3x all squared, so it's going to be x squared plus 9x squared equals 90, which means 10x squared equals 90, which means x squared equals 9. And this has already come up in this paper. X then would be plus or minus the square root of 9, which means x is equal to plus or minus 3. And then put that into your y, put those both values. So when x equals minus 3, y is equal to 3 times minus 3, so y is equal to minus 9. So one of my points is minus 3 minus 9. And when x is equal to plus 3, y is equal to 3 times plus 3, so y is equal to 9. So that gives me 3, 9. So my two values are minus 3 minus 9 and 3, 9. They've been very nice in the answer, giving a coordinate format. that tells you you've got to find the y value, because quite often what people do is they find two x values, forget about the corresponding y value. So they have been nice to us. Happy days. Right, next one says find equations of the tangents at P and Q. Right, let's go back to my diagram again. So the diagram I had originally was this. I had made the incorrect assumption that the point they give me was here. We now know what these values are. So these values here were, this one was going to be 3, 9, and this one was going to be -3, -9. And we know the gradient of the radius. So we know if that's my P and that's my Q. So we know the gradient of the diameter. The gradient of PQ is equal to 3. We worked that out in the first question. That means the gradient of the tangent at P or Q, because they're going to be the same, it's going to be the negative reciprocal of that. It's going to be -1/3. Let me just do that on the diagram. What my tangents would look like, very roughly, that's what they're going to be. Okay, so we'll look at these two separately. So I'm going to say at P, I'm going to use y equals mx plus c here. I know some people prefer y minus y1 is equal to m upon x minus x1. I prefer y equals mx plus c. So that's what we've got. And we're going to sub in the point P, which is -3, -9. So y equals -9 minus 1/3 times -3 plus c. This -9 is equal to 1 plus c, or -10 is equal to c. So y is equal to -1/3 x minus 10. Absolutely fine. You may want to multiply through by 3. So -x minus 30, but I prefer the first way, I have to say. Then at Q, again, y is equal to -1/3 x plus c. Sub in the value of Q. Q was 3, 9. Zoom in on this, sorry. Q was 3, 9. So my y value is 9. My x value is 3. So that's 9 is equal to -1 plus c. So my 10 is equal to c this time when we bring that -1 across. So y is equal to -1/3 x plus 10. And again, you might not like that third, so multiply everything through by 3. And you could have 3y equals -x plus 30. Okay, two more questions on our non-calculator paper. Everyone's favourite now, Serge's question. It says in a triangle ABC, the angle angle C is a right angle, and it says AB is equal to 2√5, BC is equal to 3. Find tan, giving your answer in surd form. So first of all, using the old SOHCAHTOA, tan is equal to opposite, so tan B will be opposite. So that's the AC over the adjacent, which is BC. So we need to find AC basically. So to find the AC, we're going to use Pythagoras' theorem. So if I call that x, 2√5 squared equals x squared plus 3 squared. Square the 2, you get 4. Square the √5, you get 5. Is equal to x squared. 3 squared is equal to 9. And that's 20 is 4 times the 5. And bring the 9 across is equal to x squared. So that's going to be 11 equals your x squared, or x is equal to √11. That means your tan B is equal to AC. We've just found AC, have we? Which is √11 over the BC, which we already knew was 3. And that's it. Okay, last question on this paper. It's a simultaneous equations question, but it doesn't look like it. We've got 2x, 2 to the power of x, times 2 to the power of 2y is equal to 2 to the power of 3. This we could write as 2 to the power of x plus 2y is equal to 2 to the power of 3, which then you could write, if the bases are the same, then the powers are the same, x plus 2y equals 3, and that's going to be equation 1. Now this one's a little trickier, not much. but we've got 2 to the power of 2x. Let's tidy this up then. That's 2 to the power of 12y is equal to 2 to the power of 2. And then that would become 2 to the power of 2x plus 12y equals 2 to the power of 2. And then that becomes 2x plus 12y is equal to 2, or x plus 6y is equal to 1. And that's my equation 2. Okay, and then we'll just work with them. X plus 2y is equal to 3 is equation 1. X plus 6y is equal to 1. That's my equation 2. And then what do? We want to eliminate the x. And I would always write that down, just say eliminate x. And I'm going to do that because the signs of the x's are the same and the same number of them. So we can just subtract. I'm just going to do equation 1 minus equation 2. X minus x is 0. 2y minus 4y is 2y minus 6y is minus 4y. 3 minus 1 is 2. Then y is equal to 2 divided by minus 4. Y equals minus 0.5. Sub that into equation 1. X plus 2 times minus 0.5 is equal to 3. Xn equal, show all my steps. X minus 1 then, 2 times 0.5 is minus 1, is equal to 3. Xn is equal to 3 plus 1. X is equal to 4. And there we have it, and that's our first paper done. Okay, the next paper then, I think I've got it here, have I? I have indeed. Right, it's paper 2, it's calculator paper, 1 hour 15 for it. Again, you see all the formulas, didn't go through those in the first one, I don't think we used any of them. Curve surface area of a cone, that was pi RL, we did use it actually, and that was it. Okay. For this paper, it says there are, probability question to start with, there are 55, question 1, there are 55 girls and 20 boys in year 13. Probability a girl in year 13 has a part-time job is 2/5. The probability that a boy in year 13 has a part-time job is 3/4. Work out the probability a student in year 13 has a part-time job. Okay, first of all, we'll get started, or do our tree diagram. It could be a girl, and they could have a job or not a job. Could be a boy, and they could have a job or not a job. So we'll fill this in. So there are 55. There are 55, right here. There are 55 out of 75 girls in year 13. That means there's 20 out of 75 boys in year 13. The probability a girl has a job is 2/5. A girl doesn't have a job then is 3/5. For a boy, it's 3/4 and then 1/4. And what is the probability that a student in year 13 has a job? So the probability of having a job, I could be a girl and have a job, or you could be a boy and have a job. So it's going to be 55 over 75 times 2 over 5. That's a girl having a job, and then a boy having a job, and that's, you just fire that into your calculator, and it comes out as a nice exact value as 37 over 75. Okay, the next one, this is very difficult for me to show on this screen here. It says rotate the triangle 180 degrees through the point 3, 1. So 3, 1, first of all, is here. Mark on your center of rotation. And then if you rotate this, and you would use tracing paper really to do this, I can't really show you on this. So I'm going to use an old school method. This is what I call the L-shape method. So if I draw that wee shape, and I rotate that through 180, it's going to be like this. So, whoops, that would take me up to this point. If I go straight down, that was down by 4. And if you rotate that through 180, it just goes up by 4. was down by 5, I should have said, so it goes up by 5. So it goes up to here. And the last one then, I go across 3 and down 3. So if I rotate that, I'll go across 3 and up 3. And there's my last point. Okay, so, but you in the exam, most people are going to use tracing paper to do that. To be honest, I would still do it this way. I prefer that way, using the tracing paper. But most people nowadays do prefer the tracing paper, which is absolutely fine. Okay, next one, calculator exam. Remember, this is a trial improvement question. You've got an equation x squared minus 6 over x is equal to 16 has a solution between 2 and 5. Happy days, I tell you that. Use trial improvement method to find the solution. So when I put 3 into this, so just to show you what I'm doing in my calculator, 3 brackets, 3 squared minus 6 over 3, and I did that, I got 7. And put it in well in your calculator once. So I got 7. I was hoping to get 16. So it's too small. TS for too small. Put in 4. So then again, you're doing brackets. So you just go in and delete what you had in before. So and delete what's in the bracket, sorry. So instead of being a 3 in a bracket, it becomes 4. And 6. And the bottom line of your fraction now is 4. And I got 14.5. So that was too big. Okay. Now that tells me, and you'd be getting a mark for this, it's between 3 and 4. The sensible thing to check then is 4.5. So you put in, change your bracket, what's in your bracket to be 4.5, change your bottom line to be 4.5, and I got 18.91. So you don't need to show it every single time. That's still too big. So we'll try 4.4. That was 17.996. Still quite a bit too big. I'm going to jump to 4.2. Sorry, that was too big. 4.2, and I did 4.2, and I got 16.2, getting close to it. Next thing you try is 4.1. 4.1 gave me 15.34, which is too small. Okay, I've got another mark here for saying it's between, I know it's between these 2 points. What I must do then is test. I have to decide which one it is. So I'm going to test the halfway mark. So write down test. And again, you're changing your bracket to be 4.15. Your bottom line of your fraction to be 4.15. That gives me 15.78. So it is slightly too small. So 4.15 was too small. That means 4.1 would be way too small. So my answer is 4.2 to 1 decimal place. Next up is an inequality question, question 4. It says, solve the following inequality. Minus 5 is less than 2n is less than or equal to 8, showing all possible integer values of n on the number line. So integer means your whole numbers. Okay, the first thing we want to do is we want just to divide through the minus 5 and the 8 by 2, which will give you an n in the middle, and then 8 divided by 2 gives you 4. The minus 5 divided by 2 is minus 2.5. So it's integer values. So we are allowed to be the 4. So we'll just put an x above the 4. We're allowed to be 3. We're allowed to be 2. We're allowed to be 1. 0, of course, is an answer. You're allowed to be minus 1. You're allowed to be minus 2. So there's all the values which go between, all the whole number values which go between minus 2 and 4, and you're allowed, because it's a less than or equal to 4, you're allowed 4. Next thing says, the dimensions of a large cylinder are twice the dimensions of a small cylinder. The large cylinder will hold how many more times as much as a small cylinder? Okay, this is about scale factor. For length, the scale factor is equal to k, and the scale factor for length is 2. Because to get from the small to the big, it's twice as big, so multiply by 2. For the area, the scale factor is k squared, so that's 2 squared, which is 4. And it will hold, so when it says it will hold, that means the volume of it. So for volume, also it could have said capacity, is k cubed, so 2 cubed, and 2 times 2 times 2 is 8. So it is 8 times as much as a small cylinder. That was about scale factor, that one. Okay, right, I have no ruler for this one. It says, describe fully the single transformation that maps M to N. Okay, clearly it's not a rotation, it's not a reflection or translation, it's an enlargement. Remember, we're going from the big one to the small. It's still called an enlargement. And the scale factor, we can work the scale factor out. I will rub this out in a second. But that is 1, 2, 3, 4, 5, 6, 7, 8, 9 squares long. And this is 3 squares long. So to get the scale factor is the image length divided by the object length. So 3 over 9, which is 1/3. So it's I know it's called mathematically, it's called an enlargement. We're actually making it smaller to get from M to N. And how you find your center of enlargement. So COE, center of enlargement. How you find it, and I'm going to do this artificially here, folks. I'm going to put on where my center of enlargement is and then show you how I get there. Right, so how you get it, this point here goes to this point. So just go through it and continue on through. This point goes to this point. So using your ruler, you goes on through, and then we'll do one more. You could have just left it at, to be honest, but we'll do one more. This point clearly goes to this point. And you can see as well, why not? Let's do them all. You can see that's where we go to. So you would use a ruler, and that's how it would work out. So that point is 3 minus 5. So my center of enlargement is 3 minus 5. You make sure you use a ruler when you do that, just to be accurate. Okay, question 7. What is this? What is this topic called? Counting, ways of counting, sure. Right, this is a restaurant that has 3 courses of its main. On its menu, sorry, so you've got starter, you've got 4 courses here for a starter. You have 5 courses for main, 1, 2, 3, 4, 5, 6 courses for dessert. There's a special deal that any 2 courses are ordered. How many options are there when any 2 different courses are ordered? So let's just work out in terms of letters. You could have it go for starter and a main, or you could go for starter and a dessert, or you could go for a main and a dessert, and that's covered them all. So you could also say go for dessert and starter, but dessert and starter is already covered. I could go for dessert and main, that's already covered. I could go for main and starter, that's already covered. So it's the same thing. So for starter and main, that is the same as 4 starters and 5 main. For starter and dessert, that's 4 and 6. For main and dessert, that's 5 and 6. So if we just work that out, that's just going to be 20 plus 24 plus 30. 20 plus 30 is 50, plus another 24 is going to be 74. Nice question. Question 8. Nice wee nth term question here. It says, find the nth term of the sequence. So this is a fractional one. If you, by the way, you got a fractional one, I guess, and maybe the first term was 1.5, what you would do is write your 1.5 as 3 over 2, and then what you're going to do is treat it as top line and bottom line as 2 separate sequences. So let's look at our top. Top line is 1, 8, 27, 64, 125. It is worth your while, folks, to learn. This is your cubic sequence. So for the top, the nth term of that is just n cubed. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Okay, now your bottom line, let's look at the bottom line. It was 2, 3, 4, 5, 6. So it's going up in ones, which tells me there's an n involved. And if I went back, this term here would have been 1. So it's n plus 1. So that's what my bottom term is equal to. So if I went back by 1, I would get a 1. So my term is 1. So I'll do another one of those just to show you here. A slightly different one. So, overall the answer then is n cubed over n plus 1. Okay, let's just make one up off the top of my head here. Right, I'm going to go for 2, 5, 10, 17, 26, and on my bottom lines, I'm going to go for 7 7, 10, 13, 16, and 19. So if I had one like this, my top line, this is almost my n cubed. Remember what n squared? N squared would have looked like this. It would have been 1, 4, 9, 16, 25. So my top line is n squared plus 1. My bottom line, let's just write it out again. So it was 7, 10, 13, 16, 19. It's going up in 3 each time, which tells me there's a 3n involved. And if you went back by 3, you're going to get 4. So it's 3n plus 4. So overall, this sequence would have been, this whole sequence would have been n squared plus 1 over 3n plus 4. So that's what you're going to have for that one. Okay, so treat it as a top line and a bottom line, 2 separate sequences, and then put them together at the end. Next, the probability that Eric will win his next darts match is 1/7. The probability that Fiona will win her next darts match is 1/5. What is the probability that they both will lose their next match? Okay, so Eric will lose is 6/7, and if you say and in mathematics, you multiply. Fiona will lose is going to be 4/5, and then just multiply along top 20 over, that's going to be 24 over 35, and that is it. So 24/35. Next one, graphs. Right, and again, this is not great. Apologies, folks, for the mess of this. Again, you will draw this out accurately. It says sketch a graph of this for the values between 0 and 5. So good, and they've given us a big clue. We wanted the table of values. So 0, 1, 2, 3, 4, and 5. And 1.3 to the power of 0 is just 1. 1.3 to the power of 1 is 1.3. 1.3 to the power of 2 is 1.69. 1.3 to the power of 3 is 2.197. 1.3 to the power of 4 is, let me just check that one. Is 2.8561. And 1.3 to the power of 5 is 3.71293. Now, obviously, you don't need to do your graph just as accurately as the number of decimal places I've gone to here. Let's plot a couple of points here. You're 0, you're at 1. At 1, you're at 1.3. So 1.3 is here. At 2, you're at 1.69. At 3, you're at 2.19. At 4, you're at 2.85. 2.85, it's going to be here. At 5, you're at 3.71. 3.71. Okay, right, so it looks almost like a straight line. It's not quite a straight line. It's an exponential graph, so it's got a slight curve to it. Try and do this in one go. That's not too bad. You know what? I'd be happy with that. That's what you've got for your question, for your graph. Next part says, use your graph to estimate the increase in x required to double the value of y. So, the easiest thing we know, when x is equal to 0, y is equal to 1. So we want to find when y is equal to 2, basically. So I want to see what increase it takes me to get to increase from here to here. So I want to double this. So I'm going to go across using my ruler. I'm going to cross at 2, at y equals 2, and see what I get. And I got, when I did that out accurately, what I got was this value here. This value here was 2.55. Okay, so use your graph to estimate the increase in x required to double the value of this. So 2.55, and you can see even here, folks, it would be starting to creep up a wee bit. 2.51 probably. It's going to be almost up at 4, so it's pretty accurate. Not brilliant, but as good as we can do. So we've tested y equals 2, and the x value was 2.55. And that's it. So just from your graph, That's the best way to do it. There's probably mathematically better ways of doing it, but that's what we want here. It says, which of the following is represented by the graph where x is the number of years? So what do we have here? By the way, we have our graph is y is equal to 1.3 to the power of x. So the first option is y increases in value by 3% each year. Okay, it's not going to be 3%. Y increases in value by 1.3% each year. Y increases in value by 13% each year, or y increases in value by 30% each year. It is going to be this last one. So the multiplying factor, if you imagine it is going to be this last one, I'll just explain why this was. Say you invested £100 and you wanted to increase it by 30%. It was 30% compound interest, it'd be 1.30, and then your n, your number of years. So that's what you would have after, with n years, you would have that amount of money. So your multiplying factor, I'll just explain it that way. Multiplying factor is equal to 1.3, so that increases by 30%. So that is why it is D. Okay, all you need to do to get that mark is write down D, but just to give you a wee bit of understanding. Okay, lovely question. One of my favorite topics. This is direct and inverse proportion. Direct and indirect proportion, whatever way you want to say it. It says y is inversely proportional to the square of x. So the first thing I'm going to write down is y equals k. That's my lowercase k, believe it or not. K over x squared. It tells you when x is equal to 15, apologies. When x is equal to 15, y is equal to 4. So we just fire those in. So instead of y, you write your 4. Instead of x, you write 15. So 4 times 15 squared is equal to k. And that means my k, just check that on your calculator, 15 squared times 4 is 900. So k equals 900. So that means your answer is 900 over x squared. Okay. Now, this then can be used, this formula can then be used to answer whatever they want. So you could use this to find your y, or you could use it to find your x. So you could use this formula. Question then says, hence find the value of x for which y is equal to 10,000. So y equals 900 over x squared. Just put 10,000 instead of the y equal to 900 over x squared. And then I would just say then multiply across by your x squared. 10,000 x squared equals 900. X squared then is equal to 900 over 10,000, which means x squared, cancel out 2 zeros on the top, 2 zeros on the bottom, you'll get 9 over 100, which means your x is equal to, square root of that, it's going to be 3 over 10. Oh, apologies, I need my plus or my minus there as well, so it's plus or minus 3 over 10 would work. Okay, right, next one, getting there, almost there. 3 more questions. It says the parallelogram ABCD has sides AB, which is equal to 10, BC, which is equal to 11, and a diagonal of AC is equal to 16. Find the area of the parallelogram. Right. First thing, what we need to do to find the area of this parallelogram, we could find the area of this triangle here, and then just double it, because this is also, this triangle is going to be the same. But before we do that, we would need to find this angle in here. I'm going to call this theta. So we're going to find theta first, and then once we do that, we can use the area of a triangle as a half AB sine C. Now what that means, if you've got a triangle like this, if I knew that side A, that side B, and I knew this angle C, I could use that formula. So it's where you've got, I talk about the jaws of a crocodile here, you've got a side as a jaws, and then you've got the angle in between them. Okay, and that is the same situation we have above. We will have up above. We will have a side, and the angle in between them. So that's what we will be up to here. So we're going to be finding the angle theta first of all, and you're going to find your angle theta from your cos rule. So the cos rule says the following. It's a squared equals b squared plus c squared minus 2bc cos a. And then I would just rewrite that as cos a, and most people learn that nowadays. I'll just show you how you would get it if you don't. If you bring the 2bc cos a across, and they have b squared plus c squared minus a squared, and then your cos a is equal to b squared plus c squared minus a squared all over 2bc. So that's, most people just learn this line. That's for finding missing sides, and learn this line as well for finding missing angles. Don't bother learning anything else as long as you understand what it means. So cos of my angle A is equal to, so if you pair this up, there's my angle and there's its opposite side, and then the other two sides are 11 and a 10. So here, if we fill that in, then cos of theta, its opposite side is a 16, so that's the equivalent of the A, and then the other sides are 11 and 10, so it's 11 squared plus 10 squared, and then 2 times 11 times 10. So let me just, this is just for the benefit, obviously you cannot highlight on your examination. You've got your theta there, and then the minus the 16 squared, and then the other ones, I had my 11 and my 11 and my 10 and my 10, and you can see compared to the triangle up above, that's what we've got. So as long as you've got cos of your angle equals, and then the only thing subtracting is your opposite, the side opposite your angle that you're trying to find, and then that's us. Okay, just do your theta is equal to cos to the minus 1 of that. So show a wee bit of working out then. Cos to the minus 1 of fraction button 11 squared plus 10 squared minus 16 squared, all divided by 2 times 11 times 10. So only go to your calculator the one time and find your theta is equal to 99.15413. Use a whole pile of decimal places, so 5 decimal places I've used here. We'll definitely use those. And then we're back over to find our triangle. So now we've got this, folks, we've got the angle. We can find the area of this whole triangle here. That's what we're going to be doing now. So find the area of this whole triangle. So your sides are in blue and your angle is in yellow. So it's going to be a half times 10 times 11 times sine of my angle down here. It was 99.15413. I've used those decimal places to get accuracy. My area worked out to be 554.29951,657. Remember what we found? We found the area of this triangle. We want to find the area of the whole parallelogram, so we need to multiply it all by 2. So we're going to say the area of the parallelogram two times 54.29951,657, which is 108.599, and we'll just give that to 2 decimal places, 108.60 centimeters squared to 2 decimal places. Okay, next question, another favourite of mine. This is a bit of 3D trig. Okay, it says ABCDEF is a straight right angled triangular prism. BC is equal to 5. Let's just label these things on. That's going to be 5 centimeters. BF, where's BF? BF is this diagonal. So BF is equal to 10. AF would also be equal to 10. Just be nicer to mark it over here. AE, sorry, is also equal to 10. And AC, okay, so AC is the diagonal across the bottom, is equal to 15 centimeters. Show that the angle between AF and ABCD is half the angle between ABCD and ABFE. Okay, right. First thing we need to do is create right angle triangles. So first of all, if I go from B to C up to F, we already know, well, do we know anything? Sorry. what do we know here? We know BC, that's a right angle, and then that's 5. And BF we know is 10. Okay, and we will work out this angle then. Sorry, we'll work out our angle here. So this is the angle between ABCD. Show the angle between AF and A is half between, yes. Sorry, this is the angle between the second one we're doing here. We're doing the angle between the base and also ABEF. So yeah, we're finding this wee angle in here. That's what we're doing at the minute. So that's what theta is. So you can just do that one directly. We can by using cos. Cos theta would be equal to 5 over 10. So that means theta will be equal to cos to the minus 1 of 5 over 10. And that works out nicely, really nicely. That works out as 60 degrees. Okay, next thing what we want to do, it says show the angle between AF and AF and ABCD is half the angle. So we're doing this one here. So if I zoom in on this, we really want to find, that's a wee right angle triangle there. We want to find this angle here. Okay, so that's what we need to find. And I don't think we have enough information to do that just yet. Let's draw that triangle out and see. So if I draw that out again, put the right angle where it is. So this is here, that's going to be my C, that's my F, that's my A, and that is 15 AC. I want to find this, I can't find this at the minute. I don't have enough information. So I need to find CF. So CF is in my first triangle. So just do the arrow here to find our CF first of all. That would have been 10 squared is equal to x squared plus 5 squared. So that's 100 is equal to x squared plus 25, or 100 minus 25 is equal to x squared, which means 75 is equal to x squared, which means x is equal to the square root of 75. So that's where I have magically got this from. That's the square root of 75. And then we can use just tan to find our alpha. So tan of alpha will be root of 75 over 15. And then if you do tan to the minus 1 of that, I'm just going to check that. Tan to the minus 1 of top line of my fraction was root of 75. Bottom line is going to be 15. And that works out to be 30 degrees. Okay, I've used up an awful lot of space there. Right, you would never do this in an exam right beyond where I'm writing, but I've just used up too much space here to show you this. Just say, therefore, show that the angle between this is half the angle. Just say, therefore, just say alpha is equal to half of theta. Okay, last question I think it is. Last question says, a box contains 8 cards numbered 1 to 8, a different number on each card. One card is taken at random from the box and not replaced. A second card is taken at random from the box. The number and 2 cards are multiplied together. What is the probability? The answer is a prime number. Okay, right. Okay, how you can get a prime number? You could have 1 and 2 could multiply together, because 1 times 2 gives you 2. Or you could have 1 and 3 could be multiplied together. Or you could have 1 and 5 could be multiplied together. Or you could have 1 and 7. Okay, now all of those could happen the other way around as well. So you could also have 2 and 1, 3 and 1, 1 and 5, 5 and 1, and 7 and 1. You could have all of those. So, and each of them are going to be, it's going to be 1 over 8 is a chance of getting the first one. The chance of getting the second one is going to be 1 out of 7. So, and I've got 4 lots of those. and then I'm going to multiply it all by 2. So if you did all of that, what you will just get is 1 over 7. So let me just go through that again. So this is one of my ways of getting a prime number, 1 and 2. 1 and 3, because 1 times 3 gives you 3. 1 times 5 gives you 5. 1 times 7 gives you 7. You could also do them the other way around. So that's why we had multiplying by 2. So multiplying them by 2 is because you could have 2 and 1, 3 and 1, 5 and 1, 7 and 1. So basically, you've got, and each one of those is going to be the same. Chances of getting there are 1 over 8 times 1 over 7. And you've got 4 lots of those brackets, which are all the same. And then you've got that 2 at the end, just as you had here. So if you just did all that, just check that. 1 over 8. And then times 1 over 7, and then times 4, and times 2, just gives you 1 over 7. The next one is a square number. So remember, you've got your numbers 1 to 8. So how can we get a square number? What are the square numbers? Square numbers are 1. They're also 4, and they're also 16 and 9, but I don't think we can get a 9. So the only square numbers you could get a 4 by doing 1 and 4. You could get 16 by doing 2 and 8. I think that's it, is it? Yeah, it is. That's all you're going to be able to do. Yep, 25 is a square number, but you can't do 5 and 5 because the 5 goes back in. 1 is a square number, but you can't do 1 and 1 because the 1 goes back in. And you can't do 9 because you can do 3 and 3. Yep, that's it. So 1 and 4. So you could do those, but you could also do them the other way around as well, remember? So you could also pull out a 4 first and then a 1, or you could pull out an 8 first and then a 2. So those are two ways of doing it, so that you've got 1 over 8 times 1 over 7. I'll just show all the working out here. Plus 1 over 8 times 1 over 7. And multiply it by 2. So what is that going to be? Just do it on your calculator. That is going to be work out as 1 over 14. And that's it. So a tricky enough wee question there to finish with. And that is it. Just check over your paper as usual.